Hey there, this is Seth Warris from Channel 9 coming to you from NDC Oslo here in the beautiful country of Norway. And I have a special guest. How's our audio? Do I sound good? They're giving me the thumbs up, ladies. I'm excited. Tell me who you are and what you do, my friend.
Okay, my name is Eran. I'm a software architect. I'm from Israel. I'm also an Azure MVP.
One of the cool things is, as soon as you emailed me, your talk is about noisy neighbors.
Right.
Why don't you describe a little bit about what that is, and I'll tell you why I'm excited about it.
Right. So during my line of work, I come to a lot of customers, and they have like their on-premise systems, and their age these days, everyone wants to go to the cloud, wants to build software as a service systems, and they come to me and they say, well, I want to get my system up in the cloud. And then we start building the architecture together, and the problem is that a lot of customers who don't come to me or other people in time, they find out this stuff too late. And they find out that when you want to build a multi-tenant system, you really need to consider a lot of things in advance when you build your architecture.
And what are those things that, and this is why I'm excited about it, because we are all moving to the cloud. It's inevitable. There's some workloads that we have there. Obviously, there's some that we keep on-prem. But when you're moving to the cloud, what are some of those things that people forget to do that are very important?
Right. So a lot of time, first of all, they forget that they need to provision resources dynamically because what they know, they ship the product to the customer. The customer installs it, he maintains it, he monitors it. Now all of a sudden, the vendor needs to install it, they need to monitor it, they need to upgrade it. And not only that, when customers come in, they want like this portal where they can click a couple of buttons, enter the credit card number, hit go, and something needs to happen backstage to get things running.
It sounds almost as if when we build software, we need to think about other people.
Right.
And that's something we seldom do as developers.
Right, and then the customers, they can come in and ask, well, what about security? How do I know that you're storing my data and that my data won't go to someone else who's not supposed to see my data? And that's really troublesome. And then you start thinking, how do I separate my tenant's data? How do I encrypt it?
Okay.
Do I need to support some sort of standards?
So there is this interesting notion, and you use the word tenant.
Right.
Let's talk about multi-tenancy and what that really means.
Right. So when we're talking about multi-tenant system, usually referring to a system where we have groups of users, where each such group, it's an organization of some sort, but it doesn't have to be. Each such group, they share access to some sort of common resources. It could be files. If we look, for example, at Office 365 from Microsoft, we have their Exchange Online and SharePoint Online, a lot of productivity tools. And if we're a company and we're using Office 365, we expect that all of our employees will have access to the same files on SharePoint, to the same teams on Microsoft Teams, to the same channels.
Right.
And if we have a user, an employee from another company, we don't want them to have access to these, at least by default. And once we have these groups of users which share some sort of configuration, some user management, some data, these are our tenants. And the basic thing in multi-tenant system is how do we separate the tenants' data from one another?
So what are some, because I know you have some cool demos that you're going to show us, but what are off the bat some things that if you're not doing, you should start doing right away in multi-tenant systems?
So first of all, you need to start thinking about each and every resource. Do you want to have it as a shared resource or a dedicated resource? And let me give you an example. Let's say we have some sort of architecture, maybe a messaging system, and we have, it's simple, a web application, a couple of storage mechanisms. So one solution would be that I'm going to provision the entire system for each and every tenant. Tenant comes in, I provision the entire system. Another one comes in, I provision everything.
I see.
But that's not really a multi-tenant system. That's what I call multiple single instance systems.
I see.
And that's a valid solution sometimes, and I've already done that, but that's not really the point.
So you're saying that a true multi-tenant system isn't where you take your app and you spin up a bunch of other VMs and then it's there. You're talking about a system that software-wise is the same system, but there's multiple groups of users that have varying degrees of access.
But I can go over each and every resource and decide, for example, that the web application is stateless, so it's a perfect candidate to be shared because there probably won't be any data that leaks between our users, between our tenants. But if we have, for example, a database which stores all the messages, we might want to separate the databases, so we have one database per tenant.
I see.
And that way, and that's a big if because we need to secure it, but if our code gets a connection string to a specific database, which is the correct database for the tenant, no matter how bad our query is, we cannot technically get data from the wrong tenant.
Right.
So we get much better security.
So your first suggestion then is a multi-tenant system to have a database for each tenant.
Right. So that's usually a recommendation, but it depends. Sometimes it will cost you too much, or it will be too expensive. It will be too expensive, or some other reason. Maybe you want to get a report across all tenants. So it's not always possible, but that's usually the way I try to go because it gives you a good way of security. The problem with that is that it might cost a lot of money, and Azure actually has some good solutions for that, like Elastic Pools.
So the interesting thing about that is you might have this really. So is there ever what do you do? Let's just say you have a company that's one of your tenants that's very large, and you have 100 other ones that are super small. Do you treat that one tenant very special and the other one's not?
So actually you could. If, for example, you're using Azure Elastic Pools for the database, which if our viewers don't know.
I don't know what it is, so hopefully you'll tell us about that.
So it's a mechanism in Azure where you can provision, you can buy a pool of resources. For example, I want to buy 100 DTUs. DTUs are database transaction units.
Okay.
And you can deploy as many databases as you like. I mean, there is a limit, but you can theoretically deploy as many databases as you like. And then these databases share a pool. So assuming not all tenants reach their maximum capacity at the same time, you get good utilization of your resources across all tenants. Now, if we have that big customer, we can sometimes treat it differently. We can sometimes say, okay, this is a big customer. We might have some sort of like a premier tier.
Sure.
We have a standard tier, a premium tier. And a premium tier, you'll get your own resource. And the customer will pay for it because he'll pay more from the premium tier, but he'll get his own resource and dedicated compute and whatever required.
And that's interesting because let me see if I understand what Elastic Pools is. Elastic Pools is you have so many data transaction units, is it called?
Yeah.
DTUs? But it doesn't matter how many databases you have in those. Well, there's a limit. But you can effectively use different databases for all your tenants, pay a flat fee for the pool.
Right.
But then when you go to a different tier, you have their own resources.
Right.
But the thing I like about that is that your coding doesn't change because it feels like they're all different databases.
Actually, Elastic Pools give us the SDK gives us a utility. It's called the shard map or shard map manager, where you can actually manage the mapping between a tenant ID, it could be an int, string, GUID, whatever, to a connection string to a database. And then you go to the shard map manager, please open the connection for a database for tenant X, and then goes ahead, opens the correct connection string, and then you can just continue working as usual.
And that does complete, and I had never heard of this, and this is really cool because it allows for complete data isolation between tenants.
Right, and at the same time, when you have multiple databases, you obviously get to a point in the DevOps cycle where you want to manage the database, or let's say you want to update the schema.
Sure.
And now instead of updating one database schema, you need to update 100 or 1,000, and that could be a problem. So Elastic Pools actually gives us tools also to run that. There's something called Elastic Job, where you can run it and it automatically goes ahead and runs it across all your databases. So that's pretty cool.
And that is really cool because then, I like that thought because if you're trying to do DevOps in a multi-tenant system that has multiple databases, as soon as, for example, you add a new table, there's a new relationship, you can run a job that will automatically do it for all of them as if it was doing it for
so I can show a short script that shows how it's done. So if, for example, let's say I have a database pool and I want to run an Elastic Job. So I need to run some sort of setup script to install the tools and everything. And by the way, all of this code is available on GitHub.
Fantastic.
So I can later on publish it in the comments where is it available. So I have a small script. Basically what it says it takes from the user some sort of credential, which the user wants to run. And then we have a short script. It says, well, if you don't have a table called test table, which is the table I want to add, run this small query, which is create the table. And then what we do, we create this job. We select our target, which again, it could be, we can create a set of databases, or if we use a shard map, then we can go directly to the entire shard map. And then we simply run it and execute it.
And it does this for every single one?
And does it for every single one, yeah.
So how do you do that with
I can even run it.
Yeah, let's do it.
I can even run it. It will ask me for my credentials. So let me enter my super secret password.
ABC123,
yeah,
of course.
something like that. And then hopefully everything works here with the internet. It should run the command. It got my credentials. Okay, it says that a new job with the name cannot be created already exists. Okay, because I ran this before.
Sure.
But when I run get the job execution, the status, then now it run completed because already ran it before, but it would have given the name. It would say in progress, in progress, in progress, and then we'll succeed. And this happens for each and every database in the pool.
I see. So how do you do that like in a DevOps cycle? Let's just say you're using Entity Framework, that it creates these diff scripts. How do you put that into the DevOps pipeline?
Okay, so what you can do is, first of all, when you use a relational database, you're inherently putting yourself in trouble if you want to have like a 24/7 up and running system.
Yeah.
Because the schema update, doesn't matter if you do it this way or another way, it inherently says that your database or your process will be down, even if it's for a second or a minute, it will be down.
Yeah.
So you need to take into account. So you can either you need to code for it if you want to stay at 24/7.
Sure.
If not, you can take the system down for maintenance, and that's great.
Yeah.
But if you need to keep it 24/7, you should either not use relational databases, or you need to code for it. For example, put your system in a read-only mode with cache, getting all the queries or stuff like that. And then you need to update your code and your database at the same time.
How long do these jobs take?
This kind of elastic jobs? So it really depends on the number of databases and what your job does. Assuming the job is written correctly and should be written like in an independent way, meaning if it runs multiple times, it will give you the same result. It orchestrates it pretty quickly. On these 4 or 5 databases, it happens within 1 second or 2. If we're talking about tens or hundreds of databases, it will take a little longer. It could take minutes or something.
Sure.
Basically, what it does behind the scenes, it provisions a couple of resources in your Azure subscription for managing this. So it creates a database and creates a worker role for running this and orchestrating, and then it will just run it in the background.
Awesome.
And you can also, when you create it, when you install it, you can also give it parameters saying what's the size of the workers you want, how many workers, and that has an effect on the speed of things.
I see. So one of the things that you've taught us is to use elastic pools to do multi-tenant databases, so each one has its own database.
Right.
What are some other tips that you have?
Right. So one other thing that I like to show is that a lot of time when we deploy multi-tenant software service systems, we need to consider that we need to monitor each and every tenant separately. Meaning we want to monitor the entire system, the request rate, the response time, and everything. But once we have these dedicated resources, we really need to be able to monitor each and every tenant separately and have alerts on each and every tenant separately. Because if a specific tenant, let's say he has his own dedicated database, and that database has a problem, or the specific server has a problem, we really need to know about it. We don't want the customer calling us, telling us, well, I have a problem, and we look at the dashboard and everything's okay, what do you want? So actually, there are a lot of methods for it. I would like to show a short demo with application insights. So again, in Azure, we have application insights, which is let me open the portal, which is a very neat solution for monitoring almost any type of application, whether it's .NET, Node.js, or any type of application, mobile applications. And what a lot of people don't know is that in the SDK, we can actually send our own, they call it custom dimensions or properties to Azure Insights. So what we can do is that if I look here at the demo, I have here like a very simple ASP.NET Core application.
Okay.
If I open the program, you can see it simply starts Kestrel. And in the startup, what I do a couple of things. First of all, I'm using a small middleware, which takes the tenant ID from somewhere. In this case, it's just taken from a header, but in the real scenario, it would be from a signed token or something, and put it in a context, in the HTTP context.
Okay.
Now, the other thing I do is when I configure application insights, I add my own, something that's called telemetry initializer.
Okay.
And we have this small class. It implements an interface, iTelemetry initializer. This is from application insight SDK.
Okay.
Oops, sorry, I wanted to increase the size. And what it does for every telemetry item which is sent to application insights automatically calls this code. And what you do is go to the HTTP context, get the tenant ID, which was set earlier by a middleware. It doesn't really matter how it's done. And then to the telemetry, we add a context item saying the tenant ID is something.
Right.
And now what happened is that application insights instantly became aware of the tenant ID for each and every request. I can filter and query by it. So if I would run this, and I ran it a few minutes before we started the session, because it takes a couple of minutes for data to get into application insights. So I'll refresh it. And we can see that about 15 minutes ago I ran this scenario, and we see that the server response time was 23 milliseconds, which you think, it's great.
That's pretty
the
good,
system works great. But if we deep dive into it, we can see that we have here one operation. It took, the median was 0.16 milliseconds, but the 95th percentile was 183 milliseconds.
Which is not good.
Which is, it might be good, it might be bad, we don't really know. But there's a pretty big variance here. So if I drill down here, we can get a bunch of charts. And I can add charts as much as I want. I can configure this, but I already pre-added a chart which shows us down here below the response time aggregated by tenant ID, the average.
I see.
So we can see that for tenants 3 and 5, we have a pretty big response time, but for the others, we have a very low response time.
Right.
Now, in our case, it's simply because my code, all it did is checked if the tenant ID is a bad tenant ID, which is 3 or 5, it punished it and caused a delay. But in real life, it could be because the database server is bad or something wrong with the data or anything else. So we can look at the charts, we can also build alerts on top of this, but not only that, we can also put it in dashboards. So what I'll do, I'll open up Application Insights is a really neat feature. It's called Application Insight Analytics.
Okay.
And I'll open it up. It's really like a full-blown dashboard. It has its own query language where you can query it for any information we want. So let me open it up. And if I start typing, we can see it has IntelliSense in it. So I can see requests. And I want requests from, let's say, oops.
You have an extra bar there.
From where I want the timestamp and bigger than, let's say, in the last hour. Something like that, and I can continue the query. Now I have it prepared in advance. Again, this is all in GitHub. I'll post the URL later on.
That's
and
very functional looking too.
To me, it reminds SQL.
Yeah.
This query language. So if I run this all the way up to here, let me run this code. It's getting my data, and we can see that for every tenant we got the results, and you can see that 3 and 5 got the worst results. But we can also render it in all types of graphs. So if I run everything now, we got it in this really neat looking graph. And this we can put in the dashboards. We can actually import it into Power BI and look at it there.
Right.
We put it like in a big control room. We can build alerts on top of it.
Right.
And then we can monitor not only the entire system, but the behavior for each and every tenant and actually react before our customer calls us.
Which is
and
good.
Us something wrong, which is very good.
Because you could set up alerts and stuff that will send you. The thing I like about this the best is that there may be one tenant that's using data in a way that no other tenant is using, where you'll never really understand that something like that's happening.
And it may be that this tenant is using more resources than it should, and it should upgrade to a better tier or a better performance. So I can call them and tell them, well, you're doing something wrong, or either doing something wrong, or maybe you need to pay more and get more performance.
Absolutely. So this is really, really interesting information. What other tips do you have? We only have a couple of minutes left. What other tips do you have for people in a multi-tenant environment? Okay,
so the biggest tip is invest in your architecture. A lot of times people don't invest enough in the architecture, even if they already have an existing system on premise. You just really need so much considerations you need to take into account. Actually, I have a talk about it in 2 hours from now. So I think it will be also available
hopefully,
for the NDC
I know
videos.
NDC does the videos as well, but yeah, absolutely.
Yeah, it will be available, I think, on Vimeo later on, so you can watch that. But invest in your architecture. Think about the shared resources versus dedicated resources. That's the biggest question. Think about the monitoring aspects that we showed. Think about security. Maybe encryption if you need to encrypt.
Of course.
Some stuff. And I think that's the biggest thing.
And those are really awesome. So before we go, why don't you tell us where these links are to GitHub so that people can look them up?
Okay, so I'll put them in the hopefully we have channel 9. I'll put it there, but it's on GitHub. It's GitHub/Eran Stiller, if I'm not correct. You'll see there's a repository there called Noisy Neighbors, and it should be there.
Fantastic. And your talk is today at what time?
1:40.
Fantastic. Well, hopefully we'll be able to see that as well. It's been super nice talking to you. This is really informative stuff. It's really cool to actually think, as I've thought about building multi-tenant applications. The Elastic Pool feature is probably one of the more interesting ones for me if I'm ever going to do that. Cool. Right? Thanks so much for spending some time with us.
Thank you very much.
Thanks so much for watching. We are going to be coming next. I think Mark Rendell is going to be talking about .NET, and we'll send that to you live, and then after we'll have a couple of guests. We are on today until about 5:40 here local time. We'll see you after this talk.